Welcome! In this video, we are going to look at how to create tables and matrices in pure Python. This is actually one of the few things that's harder in Python than in other languages. Suppose we want to create a table with m equal 3 rows and n equal 5 columns. Declaring a two-dimensional array with these dimensions would be straightforward in other languages. So for instance, this line would do the trick in C, C++, and this other line would be the equivalent for Java. But because of Python's reliance on lists instead of arrays, things are a bit more complicated. Before we proceed, I should say that Python offers very powerful libraries with ready-made two-dimensional data structures optimized for specific applications. For instance, NumPy arrays for matrix operations, pandas data frames for data science, and pillow images for image data. However, you should be able to create a table or a matrix even in simple Python, whether you need it to store a spreadsheet or you're just coding a game of battleships. And arguably, you should not introduce a dependency on any large library just for the sake of a simple table. So let's see how to create one such table in pure Python. It is very tempting, in fact, to write something like this. Times n times m. Here I'm using 0 as the initial content of each cell of the table. Essentially, the idea is to create a list with n zeros, one for each column, in fact, and then repeat that m times for each row. Let's see what this gives. Here the 3 rows are printed on the same line, but it's actually a formatting issue. Imagine these 3 inner lists printed one below the other, and you'll see that this looks close to what we want. Unfortunately though, this seems to work, but it's actually a bad idea. To see why, just try to assign to one element of the table. For instance, the one in the second row and the third column. And now look at what this gives us. You see that? Basically, the third column has been changed in all the rows. In another video, I've actually explained why this happens. I will paste a link to that video here below in the description. If we want to do this correctly, however, we need to use a comprehension to create each separate row. The correct way to do this is as follows. The inner part, actually, as you see, has not changed. But now we are using a comprehension to create each row as its own separate list. Let's look at the outcome. This is the result, and superficially, it looks the same as what we had before. However, this time, if you try to modify one of the entries, as in, for instance, table the rest of the entries, as you see, are left unchanged, as it should be. So now that we know how it is done, we can write a short function that will return a constant table in which each element is equal to a given value. Let's call it const and put in parameter m for the number of rows, parameter n for the number of columns, and an additional parameter k for the value. And in fact, we can put in a default of none so that we can simply create a table of the desired size and we can then fill it in with our data later on. So this function will return an m times n constant two-dimensional table with each element equal to k. The code is simple enough. We return list with value k times n for I in range m. Let's test this. Let's type in const for 6. And as you see, we obtain our table cut to size and ready for our data. So now that we've got this far, what about numerical matrices? It is actually quite easy to add a couple of convenience functions. For instance, one that will give you the null matrix, that is a constant matrix full of zeros, and this is normally called zeros, the function itself in algebra libraries. We can write it simply by calling the other function that we just defined and setting the parameter k equal to 0. In detail, maybe 0.0 is better here if we're going to do any calculations afterwards. Well, let's try it now. I'll type in zeros to 4, and here is a null matrix with 2 rows, 1 and 2, and 4 columns. Another classic example is the ones function, that returns a matrix full of ones. This is not really any different from zeros, except that now we pass 1, or rather 1.0, to the const function. Again, here is an example, and this produces a nice small square matrix of ones. Finally, no basic set of functions for creating matrices is complete without a function to create the identity matrix. This is a square matrix with zeros everywhere except for the main diagonal that should be set to 1. Normally, the function that returns the identity matrix is called I in the matrix libraries. And let's generalize it a bit to a rectangular matrix. So I'll put in m for the rows and n for the columns. And then let's say that this should return a matrix with ones on the main diagonal and zeros anywhere else. The main diagonal is the one coming down from the upper left corner of the matrix. Let's call this matrix ID, and let's write a comprehension to generate that. It turns out that this is slightly more complicated than the constant case that we've seen before. We will need an index variable for the rows and one for the columns. Let's call them I and j. So let us start with filling in the matrix with all zeros. But this time, let's do it with a nested comprehension. So we want j to vary over the n columns and I to vary over the m rows. Let's try this. I'll write I, 3, 3, and again we get a 3 by 3 matrix of zeros. But now it's easy to change the comprehension so that we put ones on the main diagonal. The main diagonal is where I is equal to j. So we'll just replace this 0 with the following. Let's try it again now. And here is our nice identity matrix. We just have to see now what happens when the matrix we request is not square but rectangular. For instance, let's type I, 4, 3. And as you see, this is our 3 by 3 identity matrix with the fourth row equal to 0. Likewise, if we type I, 3, 5, we get a 3 by 3 identity matrix with 2 added columns full of zeros here on the right. So this concludes our quick tour of techniques for creating two-dimensional tables and matrices in pure Python. Thanks for watching. Don't forget to subscribe to the channel and many happy lines of coding from the Apache Python.